Hello, Assalamualaikum and good day. So here we are in the last chapter, which is further differentiation and integration. So let's start with 4.1, which is inverse function and differentiation of inverse function. Alright, before I start, I just would like to remind you that this chapter is not going to pop out in your final examination. So however, you still need to study this because this will be part of your assignment, your individual assignment. Okay, so let's continue. What is inverse function? We're going to discuss what is inverse function. Okay, and we're going to look into one example, which is example 4.1, and then once you understand what is inverse function, we're going to look into how to find the inverse function. So there are certain steps that you need to do, okay? And we're going to look into example 4.3 and 4.4 to assist you on understanding the required steps here. And then once we know how to find the inverse function, you will be asked to differentiate the inverse function. And to do this, we're going to use the inverse function theorem. Okay, so the inverse function theorem, okay, is this one, this formula. And there is actually another steps that you need to understand, and for that reason we will look into example 4.5 and example 4.6 to assist you on understanding the steps involved to get the differentiation of inverse function. So let's see what is an inverse function here. Okay, so inverse function, as stated in your module, says that if f takes the value of x into b, so this is what does it means here. F takes a to b. Okay, so if a value takes you to the answer B, so the inverse, okay, we call this one, this symbol as F inverse, must take B to A. Alright, now the output becomes B, will map back to the value of A, which is the X value. Alright, so that is what an inverse function is. Okay, now the symbol, okay, -1 here, as in the F inverse. Okay, so F inverse we can write down like this. Okay, F inverse. Okay, so the -1 here, okay, it is not an exponent, okay, but it indicates a notation of inverse function where you can call it as F inverse. Okay, so we call this as F inverse. Now, not all functions have an inverse. Only one-to-one function that can have, or that can be as an inverse function. So what does it mean? It means that for each x value, it must have a unique output value. Okay, so it says here, every time you plug in the x, you will get a unique value of y, so that the y value will never appear more than once. So let's see an example for this. Okay, example 4.1 says ask you to determine if the function of y equals to fx is one-to-one function. Okay, so if you look carefully, the x value here, 1 until 7 here, will map out into a unique y output or fx output. So for example, if x equals to 1, the output will be 2. When x equals to 2, the output will be 4, and so on. So since there is no, if you notice here, okay, in the fx here, there is no value that repeat. Okay, it all has a unique output, 2, 4. There's no repeat number here. Okay, it means that this function, fx function here or y function here, is a one-to-one function. That means this function can have, alright, can have an inverse function. Okay. Okay, I just would like to add another point. Okay, I forgot to state just now. This one, f inverse does not mean 1 over fx. Okay, I hope that one is clear. Okay, so basically f inverse is not the same as 1 over fx. Okay, like you usually understand, for example, for the exponent, okay, x power of minus 1, we know that it is equals to 1 over x. Okay, this one is correct. Why? Because this is an exponent. Okay, this is an exponent. The negative 1 here, the power of negative 1 here is an exponent, so it means that it is equal to 1 over x. But as for the inverse function, okay, the inverse function here, f inverse is not equals to 1 over fx because, okay, because this is not an exponent. The negative 1 in the f inverse is not an exponent. Okay, I hope that one is clear. So let's proceed on how to find the inverse function. So let's go through the mind map. Okay, so here there are 4 main steps that you need to follow. The first one is that you need to change the fx to y. Second step, switch x and y. Third, solve for y. And the last step is change back to f inverse. So how we're going to do this, let's check it out. Example 4.3 and example 4.4. Here we are. So in this example, this question asks you to find the inverse function of fx, right? So fx is 2x minus 5. So how are we going to solve this? Right? So first of all, the original question asking you for, this is the original question, fx. The question is actually ask you to find the inverse function of fx, which is, if you write down the right notation, you should write down like this. Okay, so f inverse here is actually the same as, okay, fy. Okay, so let me put it this way, yeah. So fx is equals to y. Okay, now since this is, we are talking about to find the inverse function for fx, if you refer to the previous definition, it should be fy equals to x. It must map back to x, alright? So the fy here is actually the inverse function. Okay, now how are we going to do this? Using the 4 main steps just now. So the first one, we need to change the variable. Okay, we need to change, okay, since the question is in fx, so we change to y. So y equals to 2x minus 4. After that, we change or swap, okay, the position of y and x. So now y will become x, and x here will become y. Okay, that's what it means by switch x and y. The third step, okay, we need to solve for y. So in order to do this, you need to know how to rearrange it. It's just a matter of rearrange the function here. So 2y minus 5, because we want to get the y here, so we bring the minus 4 to the right side, okay, to the other side. So our final y value is equals to x plus 5 over 2. Okay, and the last step, we need to change the y back to f inverse. That is, just change the y here into the notation, the correct notation of f inverse. Okay, that's all. Okay, very simple. So the same example here, 4.4. Okay, this time around it has the power of 3. Okay, the function of fx has the power of 3, x squared minus 6. So following the 4 steps here, you need to change the fx to y. So it becomes y equals to x squared minus 6 power of 3. So this is the original function. After that, the second step, you switch the position of xy. So y becomes x and x becomes y. Only then you need to solve for y. So to solve for y, you need to know how to deal with the power here. Okay, this is algebra, okay. So y squared minus 6 power of 3. So you bring the power of 3 to the other side here, which is x. So x will become the power root of 3. Okay. And then y squared minus 6 is no longer have the power cube here. Okay. And your final answer will be in the form of this. So to get the f inverse, you just change back the y into f inverse, the notation of f inverse. Alright? Right, so just now, we already know how to find the inverse function. Okay? Let's see how to differentiate the inverse function. Okay? There are actually 2 methods. We have the easiest one. Alright, so if using the easiest one, it means that we are applying the inverse function theorem. Okay, but we also have the traditional method, which is once you obtain the inverse function, you can straight away find the derivative of that inverse function or f inverse by using suitable differentiation techniques that you have learned in chapter 2. Okay, about this inverse function theorem, there is a specific formula that you need to know, okay, which is this one. So differentiation of f inverse, okay, is equals to 1 over differentiation of fy or f prime y, or another way to write down this formula is this one. Okay, the pink ink here, which is 1 over f prime in the bracket the inverse function or f inverse. Okay, I'm sure you are pretty confused right now, but it's okay. We're going to see some examples later on. But before that, let's see, if you want to apply the easiest method, you need to know the steps for it. Okay, so there are basically 3 simple steps. The first one is that you need to find the derivative of fx, or it means that you need to find the f prime x, and then you find the inverse function of the fx, or the original question. You find the inverse function for it, and the third one, only then you can apply the inverse function theorem. How to do that? We're going to see example 4.5 and example 4.6. In the meantime, for example 4.5, I will explain how to obtain using the first method here, the traditional method, and the easiest method, which is by using the inverse function theorem. So let's see some examples here. Okay, before that, let's recap. So to find the differentiation of inverse function, we have 2 methods. The first one is the traditional method, and the second one is by using the inverse function theorem. So I would say that this is the easiest one, the easiest method. Okay, anyway, still, before we can go for how to do by using inverse function theorem, let's have a look into traditional method. I'm referring to example 4.5 here. So given fx equals to x squared, so the question asks you to find the differentiation of f inverse. Okay, f inverse prime x. The prime symbol here is the notation or indicator that you need to find the differentiation for this function. Okay, now if you look carefully, okay, to find the inverse function, we have the 4 main steps. The first one is we change the fx into y. Alright, so it will become y equals to x squared. This is the first step. The second step is we switch the position. Not the position. We switch the y to become x, whereas x will become y squared. Okay, and the third method is because we want to find the y, so we need to solve it. So it becomes y squared equals to x. So y becomes x. Okay, square root of x. And finally, our inverse function is by changing the y into f inverse. X equals to square root x. So this is the f inverse. Now the question asks to get the differentiation here, the f inverse prime. Okay, using the traditional method, because you are still discussing on the traditional method, we just find it using the usual way. So f inverse equals to x square root x equals to x power of half. All right, so when we find the differentiation for it, okay, so it become x. All right, so power of half, we need to minus 1, So your final answer will be half. Okay, sorry. Let me delete this. So your final answer will be 1/2 x power of half. Okay, so this is using the traditional way. So I'm applying the what we call as exponent rule, or power rule. Okay, I'm using power rule technique, okay, to differentiate this one. Now let's see how can we do the differentiation of the inverse function by using the inverse function theorem. So there are 3 specific methods here. Okay, find the derivative of fx, find the inverse function of it, and finally plug in by using the inverse function theorem. So basically this is the formula of the inverse function theorem. Okay, and how to use this? Okay, let's have a look into here. Okay, before that, let me delete this one. So let's have a look here. Okay, according to this step here, we need to find the derivative of fx. So fx is here. So what is the differentiation for this, or the derivative of it? So you just differentiate as usual, it becomes 2x. Then follow the second step, we find the inverse function of x. So the inverse function of x, I have just explained it on how to do this just now. So our final result is this one, x power of half. Okay, so this is our final result here. Okay, and then we go to the final step. You need to find the derivation of f inverse using inverse function theorem. So in inverse function theorem, this is the formula. Okay, it is equals to 1/f prime f inverse. Okay, so how to do this? It's very simple. Okay, first of all, we have this one. Okay, you already find the derivative of fx, am I right? Okay, it is 2x, so f prime x is 2x. Now if you look carefully here, we are looking for the y in the formula. Okay, there is a y, or you can write down in another way as f inverse. So it means that you substitute the x here with the result from here into this. Okay, so you have the first step here, and then you plug in whatever result you get in the inverse function here into the x here. So it become, right, so f prime y, it becomes 2x here, you substitute with x square root. Okay, and finally, if you want to find the differentiation of f inverse, okay, you just plug in with 1/, the result that you get from here. So it becomes 1/2 square root. Okay, so this is the final result for this. Okay, you may need to do it again by yourself, otherwise you will get confused on how to apply it. Actually, it's very simple and very straightforward. Okay, Now, let's have a look into another example, example 4.6. So here in this example, we are using we are applying the inverse function theorem. Okay, now let's check it out. So we have the three main steps as discussed here. Find the derivative of fx. Here we find the derivative of this one. So I will not show to you how to do this. You should be able to get the f prime, okay, of the fx here. Then we find the inverse function of fx. So from here we need to find the inverse function for it. Follow the 4 steps before. So this is applying differentiation technique. Okay, as this one you need to apply the 4 steps on calculating the inverse function. Okay, and finally, okay, by using the inverse function theorem. So inverse function theorem, again, if you write it down carefully, it is differentiation of f inverse equals to 1 over f prime y, or equals to 1 over f prime, okay, in the bracket f inverse. Okay, so to do this, you do it step by step as I show you just now. So using this formula and based on the previous knowledge from here and here, what you can do is that you know that you have f prime x is negative 2 over x minus 1 squared, and then the x here, okay, you need to substitute with the second step. Okay, so from the second step you substitute the inverse function result, which is, okay, if I write down negative 2 over, so our new x here is from the inverse function here. It is 2 over x plus 1, okay, close the bracket, minus 1, alright, square root. So is this your final answer? No, we still have the final step. Okay, so the final step, step 3, is by plugging into the inverse function formula. So it becomes 1 over the whole thing here. Okay, because this is actually f inverse y. Okay, so 1 over negative 2 over 2 over x plus 1 minus 1 square root. So to write down your final answer, okay, so actually you can settle this down first. So if you try to settle it, it will become minus x squared over 2. So from here, okay, it is actually, if I can write down, it become 1 over negative x squared over 2. So your final answer will become negative 2 over x squared. Okay, so try to do this again. This one you need to do at home, right? Do it again by yourself. Try to get the final answer like this, okay? And once you get this one, the simplification of this, only then you can plug in into the F inverse.